Hi, this is Mrs. Bear. Welcome to our algebra notes for today. This is part 2 of solving quadratics. We are going to piggyback on the factoring method that we learned in part 1. And this method is awesome, and I think it's my favorite because you don't just need to use it on equations that can be factored easily. The quadratic formula works for every single quadratic equation there is, which makes it really powerful. And if you only can learn one method, this is the one because it works for everything. So our goal for our notes today in our lecture are that by the end, you'll be able to use the quadratic formula. You'll know what it is, and you can find the solutions of any quadratic equation using it. So the mini steps that you'll need to follow in order to use the quadratic formula, you'll be able to know what A, B, and C are and get those from the standard form of an equation. And you'll be able to plug in A, B, and C into the quadratic formula to find solutions for the equation. So let's get started. All right, there it is in the big blue box. That's the quadratic formula. You can use the quadratic formula to find the solutions to any quadratic equation. Remember, a quadratic equation is one where the highest degree is 2. This is the degree right up here. It's the highest power. Okay, so it looks like kind of a mouthful. X equals negative b plus or minus the square root of b squared minus 4ac, and all of that divided by 2a. Thankfully, we have a little mnemonic device. We're going to sing it to the tune of Pop Goes the Weasel, and that's going to help you memorize this. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. You ready? We'll do it one more time. You can sing along with me at home. I promise I won't make fun of you. If I can do it, you can do it. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Feel free and pause and practice that a couple of times. I'm sure everyone at your house will think it's awesome that you're singing while you're doing math. Yay! Now, when you solve this, you'll notice that there's a plus or minus. When you're solving the equations and you're using the quadratic formula, this gives us up to 2 answers because this will just be a number. This will come out to just be a number. We're dividing by a number. So a number plus a number divided by another number gives us an answer. And then a number minus that number divided by another number gives us 2 answers. Now I'm going to show you how it's possible to not just get 2 answers, but to get 1 solution or even no solution. And if you look at the graphs, you'll see why this is possible. So a quadratic equation, when you graph it, if you were just to make a t-chart and plot values of x and y, you would find that it makes a curved shape, unlike the lines that we've talked about so far in algebra. This curved shape is called a parabola, and you'll learn about it more in advanced algebra. But for right now, know that when you find a solution, you're finding where the graph crosses the x-axis. And you can see that this graph crosses twice. This parabola only crosses once because it touches right at the very tip. So it just touches and then goes right off. And this one doesn't touch at all. So this represents no solution, where the graph does not cross the x-axis at all. This represents 1 solution, where it only touches once. And this represents 2 solutions, where your graph will go through the x-axis twice. Remember, when I say solution, you can also think of the word 0, or when you think about it in a graph, you're looking at where it crosses the x-axis, which is where the y-coordinate is 0. And you'll notice usually we write these equations as equal to y, but here we can substitute 0 in for y because we're looking specifically at where does y equal 0? Where is it crossing the x-axis? So with your song in your mind, we're going to go ahead and do some examples. So the first thing that we need to do is have an equation that's in standard form, where all of the terms are on the left side of the equal sign and there's just a 0 on the right. Now, for example, 1 and 2, that's done for you. And I bet you can imagine that later on in the examples, we're going to have you move them. But for right now, it's all given to us. So the first thing we need to do is look at the equation and find a, b, and c. So let's look at just example 1 and look at what's a. What's the number in front of the x squared? Well, there isn't one, Mrs. Bear. Remember, you can always add a 1. So the coefficient of x squared is 1. The b is the coefficient of x, -4. The c is the constant term, which is 3. There you go. A is 1, B is 4, C is 3. And now you have your A, B, and C to plug into x equals -b plus or minus the square root of b squared minus 4ac all over 2a. And plug that in. All right, -b is 4, plus or minus the square root of b squared minus 4ac all over 2a. So truthfully, this is one of our easiest methods, even though that looks like a doozy of a math problem. It's really straightforward. You're just plugging in the values of a, b, and c. Nothing too tricky. Now all you need to do is simplify. So you have to have some good math skills. So let's go ahead and start simplifying what's underneath the radical sign. We can see that 4 squared can be simplified to 16. And we can multiply 3 times 1 times -4. So we'll do that and get -12. So already it's looking a lot better. The next step will be continuing to simplify what's under the radical sign. 16 minus 12 is 4. And now remember, -4 plus or minus. This is where our two possible answers are going to come from. We're going to split this into two equations. So we're going to keep simplifying. 16 minus 12 is 4. We can actually take the square root of 4, and it's 2. That'll be uncovered in a moment. All of that divided by 2. So keep on going. We can keep simplifying. We're going to split it now into the plus, and the minus is going to come down here. So I'll just draw that, and we'll see it in a second. Let's look at the plus case first. -4 plus 2 is -2. The divided by 2 comes along for the ride. Now we can simplify. -1 is one of our answers. Now here's the minus version. -4 minus 2. That's what the plus or minus means. It means that we write two different equations. Everything else stays the same. We simplify, and we get that -3 is our answer. So now we have our two solutions for the quadratic equation, x squared minus 4x plus 3 equals 0. The answers are -1 and -3. And I've included the graph of that equation above. So what does it mean to have a solution of -1 and -3? It means that this parabola, that this graph, crosses the x-axis or has a y-coordinate of 0, because remember we were looking for where is the y, 0, and that happens where the x-coordinates are -1 and -3. All right, next example. We find our a, b, and c first. We can see that the a is 2, the b is -7, and our c value is 3. Now we'll plug those in to the quadratic formula. It's magic, right? Look at that. Now be careful. When you have a negative value, especially for b, because it's -b, so negative, a negative, make sure you put some parentheses around them so that you can keep track of the signs. So -b plus or minus the square root of b squared minus 4ac, all of these numbers, remember, are coming right from the standard form, divided by 2 times a. So we're going to simplify. And we're going to start, we can quickly take care of that. A negative is a positive, right? And then we can start simplifying underneath the radical sign. When we do that, we'll get 7 plus or minus the square root of 49. That comes from negative 7 squared. And then when we multiply 4 times 2 times 3, we get 24. And it's a subtraction that will continue. We keep simplifying. 49 minus 24 is 25. And thankfully, we can actually take the square root of 25 easily. The answer is 5. And here's our plus or minus again. That means that we're going to split it into both cases. 7 plus 5 divided by 4 and 7 minus 5 divided by 4. Those are our two possible answers. When we take the plus case first, we simplify and find that x is equal to 3. The next thing we'll look at is the 7 minus 5. So 7 minus 5 divided by 4 is 2/4 or 1/2. So the other set of solutions for this problem is 1/2 is a possible solution and 3 is a possible solution. So just like before, I'll let you look at the graph. How does that translate? That means that the graph crosses the x-axis at a value of 1/2 for x and 3. So those are two examples where you get two solutions. So what would need to happen in the formula for us to have just one solution instead of two? It's kind of counterintuitive if I'm adding and subtracting a number that I wouldn't get two different numbers. So let's look about it. I just substituted pieces of the equation with symbols because each of the symbols represents a number. So there's the negative b, which is just write a number, plus or minus the square root of a whole mess of stuff underneath there, but really it's just simplified to a number. So we have a number plus or minus the square root of a number divided by another number. The 2a simplifies to just a number as well. So how, if you think about it, can we just get one answer? How could adding and subtracting a number from another number not give me two different answers? Pause at any time if you want some more time to think. What about if that square root of a number, the red circle, what if that was 0? Well, then I'd get a number plus or minus nothing divided by another number. Well, that just simplifies to a number divided by a number. That's my one solution. When the number under the radical sign is a 0, when that all simplifies to 0, then I'm adding 0 and subtracting 0, which means I'm just left with whatever number was out front. That's what one solution looks like when you plug it into the equation. So what would need to happen for you to get no solutions? How could you get no solutions where the graph of the quadratic would be hanging out like above or maybe below the x-axis and it wouldn't cross at all? What would need to happen with the numbers for that to be the case? How could you get no solutions for something like this? What would need to be true about one of those three parts for you to get it's not possible? Think about what if the number under the radical sign was negative? In our real number system, we don't have a way to get an answer for a negative square root. So if I take whatever that number was at the beginning and add or subtract a negative square root sign, that's going to blow up for me. I can't do that. That's how we get no solutions. So when your number underneath the radical sign is negative, you can stop right there. There are no real numbers that give us a solution for that equation. So let's look at one of those. X squared minus 8x plus 16 equals 0. Our a, b, and c are 1, -8, and 16. Remember, we can always write a coefficient if there isn't one. And also remember to include any signs when we write down a, b, and c. So now we plug it in. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. Okay, I promise I won't sing that anymore. Maybe. It's kind of fun though, right? All right, so we plug in the b, -8, the a is 1, and c is 16, and then we just start simplifying. Again, we have that situation where we have a negative out in front, so that'll simplify to a positive, and we go ahead and do the multiplication indicated under here. -8 squared is 64, and wouldn't you know it, 4 times 16 times 1 is also 64. So what do you think is happening here? What do you see? Is this going to be the no solution? Is this going to be the one solution? Let's keep simplifying to find out. So we go ahead and subtract. 64 minus 64 is 0. The square root of 0 is 0. And so we're left with two cases, either x plus 0 divided by 2. And let's simplify that quickly. 8 divided by 2 is 4, so 4 is an answer. Or we'll look at the minus case of the plus or minus. And x is equal to 8 minus 0 divided by 2. Oh, look at that. We do get two answers, but those two answers are the same number. So it's a little bit deceiving to say we get one solution. We do actually get two, but they're the same solution. So we only really get one number or one place where the graph touches the x-axis. So that's what it looks like in graph form, and that's how we get one solution. Okay, let's look at the next example. X squared plus 4x plus 5 equals 0. First step is to identify your a, b, and c. Remember, do not be worried if any of the coefficients are missing. You can just add a 1. So a is 1, b is 4, and c is 5. Now we'll plug it into the quadratic formula. Again, it looks a little bit of a beast, but it simplifies quickly for you. So 4 squared gives us 16. -4 times 1 times 5 is -20. Next, we'll simplify underneath the radical sign. 16 minus 20 is -4. Uh-oh. What times itself gives us a -4? No real number will give us that answer. So this is one that's going to come out to be no solution, and we can stop right there because we don't have a real number that when multiplied by itself gives us -4. So it's not possible with real numbers to find the square root of -4, and that gives us no solution. Let's verify that by looking at the graph. You can see that graph is above the x-axis and continues on forever in the positive direction. So it's never going to come back down and cross the x-axis. That's why we get no solution. Okay, let's do a little bit of review. The first part of our series in solving quadratics talked about what to do when we could get it in factored form, set it equal to 0. Remember, that's called using the zero product property, which says that if we have two numbers multiplied together that equal 0, one or both of those numbers must be 0. We use this to solve quadratics by setting each piece equal to 0. So if x plus 5 was equal to 0, then 0 times whatever this was would give us 0. And that'll give us one value for x. That makes this whole thing true. If we set x minus 6 equal to 0, that gives us another value for x after we solve it. That gives us a solution. So let's look and see what those two answers would be. If you want to pause and get a pencil and paper if you haven't been taking notes and do these problems, Go ahead and do that, and then press play again when you're ready to check your answers. All right, so we set x plus 5 equal to 0 and solve, and we get x equals -5. And we set x minus 6 equal to 0. Add 6 to both sides and find that x is equal to 6. Both of those answers are solutions for this equation. Number 2, 3h minus 1, set it equal to 0, and solve, add 1 to both sides, and then divide by 3, and we find that h is equal to 1/3. Or we could set the second piece equal to 0, 4h plus 8, subtract 8 from both sides, divide by 4, and we see that h equals -2. Now for number 3, there's no second set of parentheses, which might be confusing, but think about 7n as in its own set of parentheses. And now you can set each factor equal to 0 and solve for n. So 7n equals 0. Divide by 7, divide by 7. So n must equal 0. And then set the second piece equal to 0. Add 4, divide by 4, and n is equal to 1. All right, now your turn. Use the quadratic formula to solve example number 4. X squared minus 2x minus 24 equals 0. Remember, the first step is to find your a, b, and c, and then plug them into the quadratic formula. -b plus or minus the square root of b squared minus 4ac all over 2a. Go ahead and pause. Grab your pencil and paper again if you need to, and then press play when you're ready to check your answer. Okay, so plugging it in, we see that a is 1, b is -2, and c is -24. Okay, plug in your a, b, and c into their corresponding spots in the quadratic formula. Those are where the b goes, a goes here and here, and c goes here. And when you simplify, you will find that you get your two answers. So 12 over 2 is 6, and -8 over 2 is -4. Okay, but what if they're not in standard form? Well, you got to get them in standard form. So move everything over to the left-hand side of the equal sign, and just a 0 will be on the right-hand side when you're done. So let's look at number 5 first. M squared equals 20 minus 4m. It's definitely not in standard form. We need everything over on the left side, and then we need them rearranged. Remember, standard form looks like the squared term is first, then comes the regular x to the first power, and then the constant c. So we need to add 4m to both sides to move that piece over, and subtract 20 from both sides to move that piece over. So there we go. After we've done that rearranging, here we have our equation in standard form. And we can look to find out what is a, b, and c. Remember, we can always add a 1 for a coefficient where there isn't one. So a is 1, b is 4, c is -20. Plug those values into the quadratic formula, and then you simplify. So we see we can simplify 4 squared is 16. All of this simplifies to minus -80, which will then become plus 80. 16 plus 80 is 96. We can take the -4 and the 2 and simplify that. -4 divided by 2 is -2. And 96 isn't a perfect square, so this is a great opportunity for you to just use your calculator. Depending on how your calculator inputs things, you might need to type in square root sign and then a 9 and then a 6. Or your calculator might allow you to do the 96 first and then hit the square root button You can experiment on your calculator. You should get 9.8. And then you'll split it into two cases. The negative 2 plus 9.8, which gives me 7.8, or the negative 2 minus 9.8, which gives you the negative 11.8. So those are your two answers or your values for m that make that equation true. All right, let's move on to number 6. Again, things need to be rearranged. We need to move that negative 8x squared over, and we need to move the negative 10x over. The 3 looks good though. We'll need to do the opposite operation. That means adding both the 8x squared and the 10x to both sides. Then we'll have the equation in standard form. 8x squared plus 10x plus 3. Find your a, b, and c. They are 8, 10, and 3. Now plug them into the quadratic formula and simplify. You can pause this at any time to check your work or to see following along at your own pace. So after we simplify, we get x could be negative 3/4 and x could be negative 1/2. All right, so here is your homework. Remember, pause on this screen, write the problems down, complete them, and then come back and check your answers. Remember on your homework to write at the top of the paper the quadratic formula so you'll have it. Maybe test yourself, sing it to yourself, and see if you can remember it. Once you have written that down, make sure that you are converting every equation to standard form. This one is already in standard form. The rest of them are not, though. And let me just add, this should be an x, 5x minus 3. There is a small typo. Now, the rest of them, you might have to do some rearranging. This one in particular, notice that there's no c. It looks like it's in standard form. A equals 15, b equals 18, but there's no third term. That's okay. C is just 0 here. This you'll need to rearrange by moving that negative 3x squared term over. Here you'll need to move over both of these terms, and then you'll have it in standard form. After you have it in standard form, identify your a, b, and c, plug them into the quadratic formula. B goes there, a goes here, and c goes there. All right, so pause and go ahead and start your homework. Here are the solutions. I'll move through quicker than you need, so make sure you pause after each page to check your work and see if you made any small math errors. At any point, you can always ask your teacher for help. Simply email them, send them a screenshot if you need to, and ask them for the help on the parts that you have questions about. Here are the solutions for number 2. Again, pause if you need. For number 3, for number 4, for number 5.